Hey everyone, in this video we will talk about a very important note regarding the distance between PV rows. So if you remember in the previous lesson when we talked about the distance between PV rows and when we talked about the usage of the solar chart in order to get the solar elevation angle or the shadow angle in order to find the distance. Now there is a very important note here, is that when we go to this website and add our location, such as latitude, longitude, and the time zone, there is something here which is important, is that when we get this sun chart will be different from in two different cases. So if you are in the northern hemisphere, it will be something like this. If you are in the southern hemisphere, it will be different. So here when we are designing, similar to what I did in the previous lesson, if you are in the northern hemisphere, you are going to design during winter, which is in the northern hemisphere is in December 21 December. This one is the worst case, between 9 to 3 p.m. okay, from here to here. However, this is really important. If you are in the southern hemisphere, the winter will be in June 21, not in December 21. So here if you are in the southern hemisphere, you will find that the lowest curve here will be June 21 instead of December 21. Okay, so this is really important. You do the same process, the same steps. However, if you are in the southern hemisphere, we are looking for the curve with June 21. Okay, so let's go and let's have an example on the sun chart for South Africa, which is in the southern hemisphere, and let's see how it looks like. So as you can see here, the same website here, and in this case I'm going to use South Africa. Okay, so South Africa have this latitude and this longitude, okay, 30.5 and 22.9. okay, 30.5 and 22.9. Now there is a very important note here, is that if the latitude in the south, or the latitude is south, you will need to add a negative sign. So let's look at here. You can see in South Africa it is south. So what does this mean? We need to add a negative sign. So you can see here I have added a negative sign. For the second one, if you are in the west, not east, you are in the west, not east, you will add a negative sign. So let's look at here. We are in east, so it will be positive. Okay, this is really important. Now the second thing that we are going to do is the time zone. So if I go here and search for time zone, South Africa UTC, it is +2. So let's go here, UTC +2 hours. Okay, then after doing this, you will click on create chart. Okay, so now you can download the PDF. Now let's compare between Egypt, which is my own country in the northern hemisphere, compared to the other case, which is South Africa, which is in the southern hemisphere. So this one is a chart for Egypt, as you can see, latitude and longitude, and as you can see here, this one is December 21. So what you can see here is that each of these curves representing June 21, May 21, April 20, a sun chart for a specific day. So for example here, 20th of March. Okay, specific day. So since I am in the southern hemisphere, Egypt in the northern hemisphere, we will choose December 21, and we will look at 9 a.m. curve, intersection between 9 a.m. curve with December 21 and 3 p.m. curve with December 21. So this is the intersection here. If you extend the line here, you will get 21 degrees, which is the lowest solar elevation or shadow angle. Okay. Another thing here is that if you remember the azimuth correction, why do we add azimuth correction? Because if you remember, since we are in the northern hemisphere, we are going to direct our solar panels to the south, which means the azimuth angle is 180 degrees. Okay, so the azimuth should be 180 degrees. However, these values here and here at a different azimuth. You can see this one at azimuth approximately 130 degrees, okay, or 125 degrees. This one, for example, is about 225, this azimuth here. However, our panels at azimuth 180 degrees. Why? Because we are in the northern hemisphere. So the distance between here and here, or here and here, the difference here, we will use this as the correction azimuth angle. Okay, so this is for the northern hemisphere. Now let's look at South Africa and understand the difference. So sun chart for South Africa. So if you look here, the first thing that you will notice is that December 21, January 21, February 20, March 20, and so on until June 21. So you can see the lowest curve here is June 21. Unlike Egypt, which is in the southern hemisphere, December 21. Why? Because South Africa is in the southern hemisphere. Another thing you look at here is that the azimuth. Since South Africa is in the southern hemisphere, the azimuth should be 0. Okay, the azimuth angle should be 0 of the panel. So you can see here 0, here, exactly here 0, compared to Egypt, which is 180, since it is in the northern hemisphere. Now another thing here you can see is also here June 21, you can see 3 p.m. here and 9 a.m. So we extend the line here until the intersection here to get the solar elevation angle and do the same process of what we did in the previous lesson. Okay, so this is the difference between sun chart of a southern hemisphere country and sun chart of a northern hemisphere country. The azimuth, okay, correction angle, because 180 is our reference. Here for South Africa also we have a correction angle because 0 is our reference. And we do the same process. So I hope this clear, something which is confusing for many of you that are living in different parts of the world.